Hi everyone, my name is Jun Fan, and now I will record for the video CPP redemption for the test 1. And first of all, I will explain about two questions. The first question is about the non-reactive balance, and the second question is the reactive balance. And the first question, let us start with the non-reactive balance, and this is the question that I chose from the last year students test, and this is question 2. And let us start our question. And this is the question that you can all read the question. And A, he called us to prepare our block diagram, so we just copy the block diagram, and here we just copy it and we just label it with the known information and unknown variable. Okay, so we just copy the block diagram, and first of all, the feed to the is comprised to two separate streams, which is stream 1 and stream 2, and given stream 1 is contain 8% of the component P, so we just label it as 8%, and the rest is R. R is 92% because the rest is only R. So all the percentage are on mass basis, so we just label it as WT, that is good percentage. So this is given the composition that non given the molar flow rate, so we just label it as N1 kg per H. And next, the stream 2 is full at the rate of 6014, 600 and 400 kg per H and contain a component P and Q. So the stream 2 is at here, so we just label that the molar flow rate is equal to 6400 kg per H, and the weight percent we don't know, so we just label it as X and 1 minus X. And the outputs of the distillation column are three separate streams, which is top, side and bottom, and the top is only the pure P, so this is only the P, so there's 100% of P, so we just label as N2 as the molar flow rate. And next that is the side stream product. Side stream product, we can see that the side stream product flow at 1380 kg per H, so we just label it as the molar flow rate, and it containing 75% of component P, so this is 75% of component P, and the rest are component Q and R. So the rest we don't know, we just label it as Y, and 25% minus Y, which is Q and R. And last one is the bottom product. There's 60% of Q and 40% of R and no P, so we just label that as the 60% of Q and 40% of R, but we just given the composition but not given the molar flow rate, so we just label it as N3 kg per H. And this two line is just given the more information. So after we plot the block diagram, so this is finished for A. So we just do the next question, which is B. Perform a DOF analysis. So we just start our DOF analysis. First, we just find the number of variable, which is N1 1, X2, N2 3, Y4, and N3 5. So we have 5 number of variable. Next, we find the number of equation. We have PQS, which is 3 material balance, so we have 3. And based on the question, this is given the information, which is the flow rate of the top product is half of the stream 1. The top product flow rate is half of the stream 1, so N2 is equal to half N1. So this is one of the number of equation. And next one is 93% of the R in the column fits axis in the bottom product. So the 93% of R is from the stream 1, because stream 2 there's no any R. So the 93% of R is equal to fit X in the bottom product. Bottom product is here, the R. So we can find the equation is 0.92 and 0.93 and 1 equal to 0.4 and 3. This is the one of the number of equation. So we can find that the number of equation is equal to 5. Also the DOF is 5 minus 5 equal to 0. After that, we can solve the question because the DOF is equal to 0. So as the question mentioned, that calculation can be done in any orders, not necessarily from A to E, so we can just start the equation. So we just find the Q balance first, and the Q balance is Q, and this is no Q, and we just sub it into the Q. After that, we can find the P balance, and it's given the information is 93%. So the information given that 93% of R in the column fits axis in bottom product. So the bottom product is 93%. So the side product is 7%, because top product is no any R. So axis product must be 100%. So 93% in the bottom product. So 7% must be in side stream product. So we can know that the 7% from the side stream product is equal to 0. This is the weight percent, so we just time with the 1380. After that, we have 4 equations and we have 4 unknown, so we can solve the simultaneous equations to find the one of the unknown. So I chose N1 I want to find the N1, so I need to count for the X, Y, and N3. So from the P, I can find that the X is 6400X is equal to this one, the first equation, and the second, I choose for the 7%, which is the side stream product. In this equation, I can find the Y, 1303Y. This is the second equation, and this is the third equation. So after that, I just sub the first, second, and third into the Q to find the N1. So I can find the N1 is equal to 3000 and something like this, N1. And after we find the N1, we can find the X, Y, and the N3. So we can know that the top product is half of the stream 1, so we can find N2 also. So the N2 is like this. And after we found all the unknowns, so we can solve the question, which is the A. It calls to find the flow. A is calls to find the flow rate of the stream 1. Flow rate of stream 1 is N1, so N1 is equal to 3000, and so this is A. B is the composition of the stream 2. Composition 2, we just put it as composition of stream 2, which is here. The composition of stream 2, X and minus X. We can found that X equal to 0.6, so 0.6 equal to 60%, and P equal to 40%. So this is B. And C is the flow rate of the top product. Flow rate of the top product is N2. So we can find that N2 equal to 1531. So this is our C. So D is composition of the side product. So D is the composition of side product. We can find that Y equal to 0.11. So if based on the question given, there's 75% of P, and Y is 11, and R is 40%. So this is our D. After that, E is flow rate of bottom product. So flow rate of bottom product is N3. So we can find that the N3 is equal to 6552. So this is our E. That's all from me for this question, non-reactive balance. Let us proceed to next question, which is reactive balance.
Hi, this is the second question, which is the reactive balance. So I choose this question from the past year question, which is the 2013, and this is the question 7. So this is the question, you all can read it. So I just start my explanation. So first of all, we can given that the two equation, and we just given that this is the reaction. So first of all, before we solve the question, we need to draw the block diagram, and before that we need to copy the equation first, and we just label it the first one equal to C1 and the second one equal to C2. After that, we can draw the block diagram, and the one input and the one output, and the input is methane and oxygen. We just label it CH4 and O2, and the output is equal to CH4, HCHO, H2O, CO2, and O2. After that, we can find that the feed of the rate contain equal amount of the methane of oxygen, and the basis equal to 100 mole per S. So basis equal to 100 mole per S. So equal molar, so it is 50%, because it is only the CH4 and the O2. So the N1 equal to 50 mole per S, and the N2 equal also M mole per S. So we find the M1 and N2, and after that we can find another equation based on the C. So based on the CH4, the initial is 50 mole per S, so we can use it to minus the C1 and C2, because CH4 is in the reaction 1 and reaction 2, and the coefficient is equal to 1, so we can just minus C1 and minus C2. How about the M4? M4 is HCHO, which is the formaldehyde. So the formaldehyde is only involved in reaction 1, so we just put it as C1, because the initial is 0, because here is no any formaldehyde. Then after that is the water. Water is H2O, so water is react in the first equation and the second equation. So we just put it as C1 plus 2 C2, because of the initial is 0, so we just put it 0 plus the C. And the N6 is the CO2. CO2 is react in the reaction 2 only, so the initial also 0, so we just put C2 because the coefficient is 1. How about N7? N7 is O2. O2 initial is 50 mole per cent, so we just put 50, and the O2 is in the front is a reactant, so we just use minus. If product, we just plus. So the reactant we just minus 1 cos C1 from the reaction 1 and 2 cos C2 because this coefficient 2. So after that, after we finish all this product, we can finish up the DOF. Based on the question given, it calls us to find the molar composition of reactants and the selectivity of the formaldehyde to compensate. Also carry out the DOF. So I start the DOF. DOF is the number of variable. After that, the number of variable N1 and N2 we already solved already. So N3, N4, N5, N6, N1 is 5, and we have cos C1 and cos C2. So the total is 7. So the number of equation also 7 because it has 5 species. There's CH4, O2, HCHO, H2O, and CO2. They have 5. So we have 5 species. And based on the equation given, the fractional U and the fractional conversion. So there's 2 information. So we have 7. So DOF equal to 0, 7%. So first of all, we need to solve the unknown because in the reactor we have many unknowns, so we just start from the fractional U from the information that given in the question. So we start from the fractional U of formaldehyde, which is the fractional U of is actual product over the theoretical U. Actual product is the actual product that produced, which is the formaldehyde SN4, and the theoretical U is the maximum product, which is the maximum product that will produce based on the reaction that the coefficient of CH4 is equal to the coefficient of the formaldehyde. So the CH4 in the initial is 50, so the maximum is also 50, so we just put it at 50, and we can find that fractional U is equal to 0.855. we can find N4 equal to 42.75. so after we found the 42.75, we can find the cos C1. Cos C1 also 42.75. After we found the cos C1, we can use the information in the question, which is the fractional conversion of methane. So we can see the methane is CH4 and CH4. The fractional conversion of methane is equal to 0.9, and the fractional conversion is equal to initial minus the final over the initial. So initial is 50 minus the final is N3 and over 50. So we can find that the N3 equal to 5 mole. Based on the equation, N3 equal to this one, and just sub it inside this, and we can find the cos C2. So cos C1 we already get 42.75, so we find the cos C2 2.25, and based on this equation, cos C2 also equal to N6, so N6 also equal to cos C2. After we found the cos C1 and cos C2, so we can solve all this unknown. So N5 equal to 47.25, and N7, all the unknown is solved, so we can solve the question in the question. First of all, we need to calculate the molar composition of the reactor output stream. In the output stream, we have CH4, HCH4, H2O, and CO2 and O2. So we need to find the molar composition, so we need to find the total, because we need to use the own molar composition to over the total. As I already found the total is equal to 100, so the molar composition is use the molar composition of each product, like CH4% over the total and times to the 100%. So we can get the percent from the CH4, HCHO, and H2O, CO2, and O2. This is the percent molar composition. And after finding the molar composition, we need to find the selectivity of the formaldehyde that relative to carbon dioxide. And the formaldehyde to the carbon dioxide, formaldehyde HCHO is equal to N4, and to the carbon dioxide is CO2. So CO2 is N6 and N4 over N6. So just now we found the N4. N4 is equal to 42.75 N4, and N6 is equal to N6 is 2.25. So we just divide by 2.25, and finally we can find the selectivity, which is 19. The final answer. And that's all from me, and hope you all enjoyed the video and learn. Thank you.